All right, let's look at a couple problems from 1.1 and 1.3. Our first problem up is on a number line. Suppose point E has a coordinate of 5 and the length of line segment EG is 10. What are the possible coordinates of point G? So I'm going to do this two different ways. I'm going to start by drawing it because visually a lot of us do better. So I'm going to put my number line here and I'm going to just label E and G. This is one potential, right? That G is to the right of E. Alphabetically, it's that way, so I kind of predisposed to do that. I know the value of E is 5, and I know the difference is 10, right? Because the difference is the length between 2 points. This is what are the possible coordinates of point G. Well, I know if I have a 5 here, then 5 minus G gives me my first equation. But remember, this is length, so we're doing absolute value. So what we actually want to consider is 5 minus the absolute value of G equals 10. And then, of course, that's going to break down into two equations. And we'll do those in just a second. But for now, I know the length here must be 10. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's going to put me at 15. But I can also go to the left 10. And that's going to put me, so I'll call this G1 for the first G that we found. And I'm going to put G2 here. Obviously nothing's to scale. That's fine. We don't trust our eyes in this class. Go back 10. And then that would just give me 5 minus 10, which would be negative 5. So my possible points for G would be negative 5 and 15. Now let's see if our absolute value equation would work out the same way for us. So we're going to do 5 minus G is equal to 10, or once we drop those absolute value bars, 5 minus G is equal to negative 10. Subtract 5 from both sides, and I get negative G is equal to 5. Of course, then I divide by negative 1, and I get, let's put it in this color. So that's our first G way. Our first point now here, 5 divided by negative 1 is negative 5. And if I solve it here, if I do minus 5, I get negative G is equal to negative 15 divided by negative 1, because we never leave that negative sign in front of our variable. And that's going to yield G is equal to 15. Both methods are in agreement, so we should feel pretty confident about our answer there. All right, before we move on to the second problem, I want to look at one of the more frustrating parts of using savasrealize.com, and that's user error. Now, there's a bunch of different types of user error, and there are even times where it's actually a site error, and then I usually can report those and they get resolved, or they point out something we missed and said, oh no, it was actually user error. So here I went to check my answer just because I want to make sure the videos go out with the right answer. And it's telling me the correct answer is 15 and negative 5. I knew that was right. So I kept clicking submit answer, and I kept getting told it was wrong. You get 3 tries before they give you a new problem and they tell you what the correct answer was. My gut reaction was, well, that's not fair. 15 and negative 5 is correct, but I put negative 5 and 15. Does the order matter if it doesn't specify? It's not going to matter if it doesn't specify. But my mistake was actually right here. That is a decimal and not a comma. So if you know you got the right answer, actually evaluate the feedback you're given and don't just click through it. Otherwise, you're going to be doing a whole nother problem because you pressed the wrong key. Did all the work right, but pressed the wrong key. All right, problem number 2. How can the segment addition postulate be used to show that AE, so line segment AE, is equal to AB plus BC plus CD plus DE? Well, let's see if it can even be used to do that. So that runs from A to E. And then it's showing AB, BC, CD, and DE as the sum. Those sum together will equal AE. So let's see if that's true. So we have AE is equal to AB. Let's not use that color again. Plus BC plus CD plus DE. So is my purple, blue, green, and orange equal to my blue? Well, to use the segment addition postulate, we know we have to have, for every part that, where every line segment ends, the next piece must pick up as the beginning point. So AB ends with B and BC begins with BC, so we can't add those together. So this part's good. And then we go from C to C, so we can continue this line to here. And then where we pick up on CD, the endpoint is D, and the starting point of DE is D. So we can do that. And we have shown visually that yes, that is how we would do it. We can show it by AE is equal to AB plus BC plus CD plus DE. Now I'm not showing the 4 answer choices. See if you can determine that on your own. Make sense out of them. And we'll see you on the next problem. Alright, for this problem it wants us to find the length of line segment AB. So I'm just going to identify my A and my B. So A is equal to 3, or A's coordinate value is 3 and B's coordinate is 7. So I have 2 options here to solve for the length of AB. I'm going to go using the A minus B's absolute value to get AB's length. So I have 3 minus 7, find the absolute value of that, and then I get the length of line segment AB. Well, that is the absolute value of -4 is equal to AB's length, and that just means that we have a length of 4 for line segment AB. And then we're just going to verify that by doing the counting method. 1, 2, 3, 4, and we're good to go. All right, let's talk about a couple things that we really need to know before we start solving this. I know we have talked about them in today's lesson, but I just want to make sure that we remember a couple things. So, a straight line, also called a straight angle, measures always as an angle measure of 180 degrees, and the vertical angles theorem, I'm going to call it VAT from now on, tells us that if we have 2 lines intersecting, then 1 is congruent to 3 and 2 is congruent to 4. And if we have that information, we can solve this problem. And what we're going to do is start with what we're given, right? We have a conditional here. If something, then find something. So if KNM is equal to 54 degrees, so I'm going to look at K. Oop, I should probably put the straight line on. So this looks to be point K, and then I have N, and then I have M. So it looks like it's the triple tick. So I'm just going to come down here and put tick 3 is equal to 54 degrees. And I'm going to also make a note that that was my given. And that's because what we're going to be doing coming up is going to be important to know what's given and what we're working towards. So if I have 3 tick marks, it's equal to 54 degrees. And it wants me to find F and D. So I'm going to use, let's do a new color, F and D. So start at F. Oh, this one's going to be easier than I thought. F and D also has 3 tick marks, so I'm just going to put T3 there. And by the tick marks, we automatically know that F and D must be 54 degrees. Well, that wasn't very much fun, so let's do something a little bit harder because there's definitely homework questions about it, so I want you guys to see it before we get past it. What if I wanted to find, so this is a whole new problem, we'll call it corollary. You'll get tired of that word soon. It just means in addition to. So I'm going to find a color I haven't used yet. And now I'm going to say find, let's do the measure of angle D N M. I'm just going to come up here. Here's D to N. Here's N to M. So it's going to be this guy right here. Well, if I know that this here is 54 degrees, and I know that the straight line DK so the measure of angle DK that goes from here to here is a straight line, and that's 180. And then I can look at angle DNM plus MNK, so my pink line and then the flipped over version of this. Those two added together give me the line DK. So I can say that this is also equal to the measure of angle DNM plus MNK. And now I have to say, do I have anything that I can substitute here? Well, MNK is 54 degrees. So then I have 180 is equal to, I'm going to change this to an X just so it's a little easier to work with. You guys now have absolute freedom. You're done with Algebra 1 to assign variables at will, as long as you go back in and make sure you check them. So now I know that that straight line is equal to 180, or 180 is equal to X plus 54. Subtract the 54 from both sides. That leaves me 126 is equal to X, and therefore D and M is equal to 126 degrees. And then if we kind of go back here, let me see if I can paste this just for clarity's sake. And then move it right here. If we were to look at my vertical angles theorem and superimpose those same angles there, I would have 1 here, 2 here, 3 here, 4 here. Well, we knew here that angle 2, which is right in here, is already 54 degrees. And then we could look at angle 4 by the tick marks must also be 54 degrees. Well, that also works with our vertical angles theorem, which we now know is a theorem. So that means we can always rely on it. And then for angles 1 and 3, well, they're going to be congruent because by vertical angles theorem, they must be congruent. So then they're automatically both 126 degrees. And that is how you do 2 problems in 1. Alright, so let's look at this one. I modified the problem just a little bit, only because there's not a lot of questions on the homework, so I didn't want to do one of them right off the bat for you. So we're looking for the midpoint of line segments AB. The midpoint's just the middle. Think of the middle always as the average. And how do you average something? you take the number of elements or the number of numbers, add them together, and then divide it by the number of numbers you used. So if I have A at 2, -7, and I have B at 2, 8, I have my first x value, I have a second x value, I have a first y value, and I have a second y value. We have to keep our same variables together. So if I'm finding the average of my x values, I'm just going to take x1 plus x2 and divide it by the number of x's that I have in this problem. So that's just 2. And when I do that, I'll have my x coordinate. And I'm going to do the same for the y's. I have y1 plus y2, and that's divided by 2 for the 2 y values I have. And that is exactly where the formula comes from. Notice that I put numbers underneath my coordinate points. I put x1, y1, so when I plug this in, it's much easier for me not to make a mistake, to not fumble it on a video and then have to restart. So I know that 2 is equal to x1, so I'm going to make that substitution right here, and I'm going to say 2 plus, and then x2 conveniently happens to be 2, over 2 will give me my average, or my middle point of my x coordinate change. And then for my y's, I know that this one is -7, so my y1 becomes -7, plus my y2, which is 8. So I'm going to put my 8 up here, and I have a 2 here. And now I have two expressions, one in blue for my x coordinate, one in green for my y coordinate. And when I solve these expressions, I will have the midpoint of my line segment. So 2 plus 2 is 4. And I'm going to leave that over the 2. Now I have -7 plus +8 is 1 over 2. So that is technically my term, but we always want to put it in simplest form. When you go to put it into Pearson, it's going to require that it is in simplest form. So 4 over 2 becomes 2, and 1/2 is in simplest form. So my midpoint of AB is 2, 1/2. And we can plot that on a chart. It's not asking us to do that. One of the nice things about geometry versus algebra 1 is we're not going to be doing a lot of graphing until we get to topic 10 and 9. And then we're going to hit graphing for a while, and then we're done again. Alright, let's talk about one of the most famous problems in geometry. This typically gives the most trouble in topic 1 as far as 1.1 and 1.3 are concerned. And that is the partition, or segment partition, or traveling a certain length along a line segment. So this one really is important to start with reading the question and making sure we understand exactly what it's asking. It says find the coordinates of the point 7/10 of the way from A to B. So if you're going from home to school, that means you start at home and you go to school. So we have to start at A. So I'm just going to put here, start at A, go to B. And that's just so that when we get to the final step, before determining where we're going to rest on the line, we know to add those values to A. Alright, the 7/10 is not too important right now. What we need to do is talk about how to find the change in X and the change in Y. So in the video and in class, when I did this for you, I used this symbol. I'm just going to write it up here. This means the change in, and then whatever variable I put down here is the variable we're looking at. So, or the axis that we're looking at. So right now we're looking at the change in x-axis. Where here we're looking at the change in the y-axis. So really, kind of like we did on our previous problem, we can now, well, let's simplify it. Let's do this really easy. This is a trick that I like. I didn't know it had a name until after I recorded the video for today's lesson for our TBD learners and our YouTube learners. This is called the taxi cab method, apparently. And the way to imagine, or the way that they kind of made it make sense, is our coordinate plane. This graph is a city layout, and we obviously can't drive through, cutting through blocks and stuff, right? There's homes, there's schools, there's buildings. So we have to follow the grid, and we have to figure out what would be the most efficient way for a taxi cab to travel from A to B, making as few turns as possible. So if we start at A, so it's 11, right? Yep. We could travel straight down this road and then go straight up here. Oh, well, that's good enough. So if we do it this way, and I like it this way because now when we look at the change in x, we can see that we went from -3 to 11. So I just need to know what is the distance from -3, or between -3 and 11. And that's going to give me -3 minus 11, -14. And since we're talking about length, it must be positive. So we now have that the change in x is 14. So I'm going to come up here just to organize my work and say that the change in x is 14. I'm going to do the same for my y values. Since it's a distance, I'm going to go ahead and set up with the absolute value bars. For the y's, I went from -7 all the way up to 5. So -7 minus 5 is equal to the absolute value of -12. And the absolute value of -12 is 14. So now I can come up here, say my change in y is 12. Here's where a lot of people are saying, okay, we're done. We've solved the change in the y, the change in the x. But that's the total value you actually have to travel along your x plane and then your y plane to get from A to B. But we don't actually want to travel that full distance right now. What they're asking is, where from A up to B would we stop at 7/10 of the way? So let's say you're going from school, or from home to school, like I mentioned earlier in the problem, and you need to get gas, and you went to the gas station to be 7/10 of the way along this line. Even though you calling this a taxi cab method, that means you would have to cut through, but that's just a visualization to get you the change in x and y. Now we're just looking at the red line, where it's 7/10 of the way from A to B. To do that, we now need to take our change in x and our change in y and multiply them by the value that we want. So we want to know 7/10 of the change of y, and we want 7/10 of the change in x. Oops, not ready for that to close yet. And to do that, we distribute the 7/10 in. So here we get 7/10 of the change in x is equal to, and I'm not going to do 7 times 14 without a calculator right now. So I've distributed this in, and I've got 7/10 of the change of x. Now I'm going to distribute this in, and 7 times 14 is 98. And that is going to stay over 10 because we're doing 7/10. And 98 divided by 10 is 9.8. So that is my new x. This is the 7/10 x value. And I'm going to do the same here. 7 times 12, a little easier, is equal to 84 over 10, which gives me 8.4. And that is my y2. So our total change 7/10 of the way is now the x changed by 9.8 and the y changed by 8.4. So what we have to do now is, since we're traveling from A to B, is take our A coordinate where we started and add our change in x. So what we're really doing is doing x1, that's where we started, plus the change in x, comma, y1 plus the change in y. And that'll give us our final spot, 70% along the way. So x1 is -3. And to that we need to add 9.8. And our initial y was -7. And we need to add to that 8.4. So -3 plus 9.8 gives me 6.8. And -7 plus 8.4 leaves me with 1.4. So I'm going to say this is roughly, just so we can do a quick check, is 7 and 1.5. So I'm going to go to x is 7, which is here, and 1.5 is here. So this point, let's do it in orange. This point is 7/10 of AB.